types of problems, these Fnet equals 0 problems, when you have your forces that are balanced. So the first thing that you want to do is you want to draw a free body diagram. We spent some time last week doing this. I had you guys do it with me, and you guys did it on your own. Remember, you can't have any components on a free body diagram. You can't have Fnet, you can't have velocities or accelerations. If you have anything at an angle, you should be angry. And that anger should cause you to resolve those forces into X and Y components. Somewhere besides the free body diagram, you're going to take that arrow, you're going to break it into two arrows that will do the same thing. Then you're going to write down the equation Fnet equals 0 for the ups minus down forces. Then you're going to write Fnet equals 0 for the right minus left forces, and you're going to solve the equations. A 10 Newton block is being pulled horizontally across a rough surface with a coefficient of sliding friction of 0.5. If the block is moving at a constant speed, find the normal force, the force of friction, and the tension. All right, so there's my dot. That's going to be my block. I'm going to put down the forces on this block. And I'm going to say that, okay, it is being pulled. I have an equal and opposite force that is friction because it is not speeding up. And we also have weight going down and normal going up. All right, so I know the weight because that's 10 newtons. So I'm going to find out what the normal is. And so I'm going to say in the y direction, Fnet is equal to 0. Why? It is at rest. Even though it's moving side by side to side, it's not going up or down. So I'm going to say my up arrows minus my down arrows equals 0. So I have N minus mg is equal to 0. So N is going to be equal to mg is equal to 10 newtons. Now that I know what the normal is, I can get friction. Because I know that that should be mu K, not mu S. I know that my kinetic friction is 0.5. And so I know that the force of friction is going to be equal to mu N. And so this is 0.5 times 10 newtons or 5 newtons. Again, no units because it is a ratio, like pi. It's a ratio of two different forces. The force of how hard it is to lift something and how hard it is to drag something. All right, now I can look at the x direction. In the x direction, my forces are balanced as well. Why? Not because it's not moving, but it has a constant velocity or a constant speed. So now I'm going to take my rights minus my lefts. So just like in math, I'm taking things that are going to the right as positive and things that are going to the left as negative. So this is going to be F minus T is equal to 0. And so T is going to be equal to my friction, which is 5. See if you can do this one without me. One thing to note, and feel free to slow that down as slow as you want it to be to follow all that. When I substitute in for G here, I didn't substitute in as negative. I put it in as positive. What did that negative tell us about G when we put it in projectile motion? Yeah, it told us that it was directed down. This is still directed down, but I already took that into account when I did ups minus downs. So this minus here is the same as that being negative 10. And so I don't want to put in negative 10 again because I'm doing it twice. And that would lead us to take it to be up because a negative of a negative would be a positive. All right, how about if we're dragging one at an angle? Note that the weight and normal are not equal to each other because there are two things in the y direction that are acting on this box. So I need to, somewhere else, look at my components. And I'm saying that Tx and Ty, even though they're not real, are vectors that could take the place of T together. They do the same thing as T. They are its components you can resolve it into. T of x is my adjacent side, and so I know that T of x is going to be T times cosine of 30. T of y is my opposite side, so I know T of y is going to be T sine 30. And so I can put in my values. And so 10 sine 30 is 5, 10 cosine 30 is 8.7. All right, so I need friction and normal to get what our mu is. Friction I would get with the x direction. And so in the x direction, I would say Fnet is 0. Not because it's not moving, but because it's moving with constant speed. And then I'm going to take the forces to the right minus the forces to the left. So I'm going to have T cosine of the angle minus F is equal to 0, which I know what this is, but I'm going to put it in just as variables to start with. And so my friction is going to be this 10 cosine 30, which we got to be 8.7. In the y direction, Fnet's also 0 because it is not moving. So when you drag something sideways, it doesn't lift it up or down, hopefully. It's just going side to side. So we would say it's at rest in the y direction. So now I'm going to take my ups minus my down. I have two ups. I have T sine of 30 and I have N. Both of those are acting up, so I'm going to make them positive. So that's going to be T sine of theta plus N. I have one down, which is mg. That's why I made this a bigger arrow, because there's two arrows that balance it, even though one of them is fictional and isn't allowed on our free body diagram. All right, so N is going to be equal to mg minus T sine of 30. mg is going to be 5 times 10 T sine of 30 is going to be 5. Again, I don't put in the negative because I already did. I put it in here. So I already said it was negative, so I don't have to do it a second time. So I have 45 newtons. Then I can plug that in to get my mu of K. So this is going to be 8.7 newtons divided by 45 newtons, which I'm going to get a calculator, but I feel like it's really close to 0.2. .19. No units because it is a ratio.